Welcome back. In this video, we're going to take a look at how we use synthetic division and its application. So, for us to use synthetic division, the divisor has to take the form of a binomial. It has to have a leading coefficient of 1, and it should just be 1x, or minus 2 plus 2 minus 3 plus 4, doesn't matter, as long as it's an x minus or plus something. And then the dividend can be any polynomial. We just have to make sure that we're in descending order of power. So if we don't have a descending order of power, we put 0 in its place, which we'll see in the next example. So here's the setup. We take what makes this a 0. So if I put negative 2 in for x, that makes this 0. So I put negative 2 here. And then I move all the coefficients of all the terms along this next row. So this is the coefficient row. And then the process is simply, we bring this first term down, you need to remember that, and then it's multiply and add. Multiply and add. Multiply and add. And what we get is 1 less power for each term, since we're dividing an x into this cubic term, quad term, and this linear term, and then a constant. So these are the coefficients of 1 less power of x. So we have a 3x squared minus 4x plus 4 minus 7 over x plus 2. Now we can check our answer, just like when we did with long division. We can take this divisor and multiply it by each of these terms, and we should end up with this dividend. Now let's take a look at another example. In this example, we have a missing cubic term. So when I write this out, I first put in the 0, which is a 3, and then I have a placeholder for the cubic term. I've got 1 as the coefficient for the 4th degree term, and then I've got a 0 for the cubic term, and then negative 2, and then 1, and negative 4. And it's the same process. So bring the first term down, multiply, add, multiply, add, multiply, add, multiply, and add. So again, it's 1 power of x removed. So x cubed, x squared, x 22 plus 62 over x minus 3. Now, let's take a look at the next slide. Why do we care? Well, it turns out that we use synthetic division to help us when we solve for zeros of a polynomial. So if you have an equation of a polynomial and you are given one of its roots, we're given the root minus 4, we know one of the factors of this polynomial. And we should be able to divide this factor into this polynomial to find the other two factors. So this is where synthetic division comes in. Handy, especially if we can do it quickly. We know the 0 for this term is minus 4. Here we have all descending order powers of x, so 1, negative 2, negative 19, and 20. And then through synthetic division, we bring down the 1, multiply the negative 4, add, multiply, add, multiply, and we get this quadratic. This quadratic, x squared minus 6x plus 5, can be factored into x minus 1 times x minus 5. So now we can write the equation of this polynomial in intercept form because we have all three factors. We have this factor and then these two factors. So our polynomial in intercept form is x plus 4, x minus 1, and x minus 5. And since the a term is 1, the a term is 1 here. So that's why we do synthetic division. That's why we care about you doing it properly. So, if you have any questions after viewing this, please ask me in class or come in before or after school. I hope you find this helpful, and until next time, bye-bye.